Good morning all. Our discussion is initial stresses. So, when you insert a nut over the bolt and tight it, especially when two members are joined like this. For example, see these are the two members joined. This is the nut and it is the head. So here you have inserted a nut. Okay. Now you have tightened it. So as in when you tighten it, here the shank portion of the nut is subjected to tension. Tension means tensile force. Is it right or not? When you are tightening it, then this bolt will be stretched. So due to that tension or due to the tensile force, there are some internal stresses. Tensile stresses are developed inside the bolt, due to which this bolt may fail. So that is the first category in this initial stresses, that is, this is the first category, tensile stresses due to stretching of bolt. When you tighten it, the bolt is subjected to tension. So due to that, tensile stresses are developed and the bolt may fail. So this is the first category, and here this can be calculated by using this formula. Tensile stress T is equal to this load by area. Then what is this load? This is the load due to tightening. The load the bolt may experience due to tightening, and this load can be calculated by using this formula. This is an empirical formula. P is equal to 2840 into D. P is equal to 2840 into D, where D is the diameter. Is it nominal diameter or core diameter?
Nominal diameter.
D means it is the nominal diameter in mm. So if you substitute the diameter in mm and calculate this value, then you will get the force due to tightening in newtons. So here P is force due to tightening and the units are in newton. So remember, you have to substitute the value of D in mm, then you will get this value in newtons. Okay. So this is the tensile force which is developed inside the bolt due to tightening. Okay. Now, here if you want to calculate the diameter or if you want to calculate the area, then area is equal to P by sigma T. And here area, what is the formula for area? Pi by 4 DC square. Here in this case it is DC square. Here we have to use core diameter. Remember, here this is nominal diameter, but this is core diameter. Okay. Pi by 4 DC square is equal to P by sigma T. Here P can be taken from this formula, and sigma T is the stress developed, and this is the core diameter of the bolt. Okay. So by using this you can calculate the value of the safe value of the bolt diameter, core diameter, for initial tightening. The second type of stress which is developed due to initial tightening is shear stress, which is torsional shear stress. What does it mean? It is the shear stress developed due to torsion. What do you mean by torsion? This is the bolt and you are inserting the nut and then you are rotating. So it moves freely up to the surface of the body to be joined, and afterwards you have to rotate it with force. So in such cases the bolt is subjected to twisting. So here you are trying to rotate the nut by forcefully, but it will resist its rotation. So that's why there will be torsional shear stress which is developed inside the bolt, where sigma b is the bending stress developed and x is the distance between this surface and this surface. Okay, so this surface and this point. Okay, so this is the distance that is called as x, and it must be in mm. Okay, and E is our modulus of elasticity. So here x is in mm and E is modulus of elasticity or Young's modulus. So this is in newtons per square mm, and L is the length of the bolt. L is length of the bolt. So by using this formula you can calculate the bending stress, and this is a special case where the surface of the member to be joined is not perpendicular to the axis. In other cases like this, the bending stresses are not developed. Okay. The next type of stress is shear stress across the screw thread. Say here, assume that this is the shank of the bolt and this is the thread. Like this, say this is in helical form. Like this, a thread is cut on this. Now, when you are tightening, this thread may be stripped out of the shank portion. So this is due to the shearing. See, when will it strip? So this is due to shearing like this. Then only it will be separated. It cannot be taken like this. It is due to shearing, especially when you are tightening the nut inside. So there are similar threads in the nut also, and this is the thread on the bolt. So when the thread in the nut, say for example this is the thread in the nut, this will apply some force on it, due to which it may be stripped like this. So it may be sheared off like this. So due to that shearing it may fail. Okay, now that shear stress can be found by using this formula. Once again, shear stress is equal to P by area. So P is the load. So one thread is the thread on the nut is applying force on the thread on the bolt. That's what I tell now. I'm saying now. See, for example, this is the thread on the nut, and there is another thread which will come in contact with this nut, with this thread on the bolt. So that is the thread on the nut. So when you tighten it, this thread on the nut will apply some force on it. Due to this may be stripped like this. So that is shearing. Now what is the resisting area in this case? Tell me. What is the resisting area in this case? See, the thread is wound like this. What will be the resisting area in this case? Now, if this thread is separated like this, actually this area is in contact with the bolt portion. So, if there is some force, this area will resist from separation. Is it right or not? So that's why this area, so this is that area. మీకు బయట కనిపిస్తుంది కదా, ఈ ఏరియా దాన్ని రెసిస్ట్ చేస్తుంది. సో ఈ ఏరియా ఎలా వస్తుంది? అజ్యూమ్ దట్ వన్ కంప్లీట్ రెవల్యూషన్ ఆఫ్ ద థ్రెడ్. ఓకే, సో దీని కింద ఉన్న ఏరియా ఎలా వస్తుంది మనకి? ఇట్స్ థిక్నెస్, దిస్ ఈస్ ద థిక్నెస్ ఆఫ్ ద థ్రెడ్ multiplied by this length will give us the area. Is it right or not? So this length multiplied by its thickness, where T is the thickness of the thread, will give us the area. So tau is equal to P by thickness into length. So how do you get this length? This is cylindrical. Is it right or not? So we have to take the circumference as the length. Am I right or not? See, if this is complete one revolution, so if you know the diameter of the circle, then this length can be found by using that formula pi d. See, this is the circle. So the thread is wound like this, where d is the diameter. Now its length can be found by using the formula pi d. So that length into thickness. So pi into d into t. So this is for 1 ton. There may be number of tons like this on this thread. Then only the screw is formed. So that's why for 1 ton this is the resisting area. For n number of tons into n. Did you get my point? So this is the total resisting area. This is the resisting area for 1 revolution of the thread. And this is the total area. This is the area of resistance for n revolution. The total, if there are 10 revolutions, say for example if this is the bolt, from here to here there are 10 revolutions, then you have to take 10. That will be the resisting area for this. Okay. Now by using this formula you can calculate the required values. So the shear stress is equal to tau into pi dt into n, where here d is external diameter or nominal diameter and t is thickness of thread and n is number of threads. N is number of threads in contact or in engagement. What does it mean? There may be number of threads on the bolt, but only few of the threads are in contact with the nut. Antena? So nut lo kon threads untai. So when you insert it, only few of the threads are in contact with the nut, or not all the things. See, if you tighten a nut, some threads may be outside. Is it right or not? Only the portion over which the nut is there, only those threads are in contact with the nut. So the force will be only on those threads only. So that's why we are taking n as number of threads in engagement or in contact. Right. Next type of stress is the crushing stress. Do you know what you mean by crushing stress? It is nothing but compressive stress. See, for example, you have taken it and when you are applying force like this, so this is nothing but crushing. Due to this, this object may be crushed like this. Sugarcane crushing, you might have seen that. What happens when you insert the sugarcane into the rollers? So that is crushed like this. Crushing force is applied. In the same way, when two threads are in engagement, see, if for example, if this is the thread on the bolt and another thread will on the nut will come like this. Now this thread will apply force in this direction, and on the other side there will be another thread of the nut. On the other side there will be another thread of the nut. See, these two are the threads on the nut, and the center one is the thread on the bolt. So when they are in engagement, these two threads may crush the thread on the bolt. So due to which that particular thread may be crushed or compressed. In such case also that may be failed. Okay. Now crushing stress is sigma c, which is equal to once again P by area. So the formula is same for anything, P by area. Here the resisting area is the only difference for different types of stresses. So the resisting area is different from tensile stress. It is different for torsion shear stress, bending stress or shear stress. Like that, the area is the only difference. Right. Now how do you calculate this area? See, if this is the thread, if this is the nut over which this is the thread, is it right or not? So this is the thread. Now if another thread comes over it when the nut is engaged, this nut will apply some force in this way. Is it right or not? It will apply some force in this way, due to which it is crushed. Now what is the resisting area? This is the resisting area. Am I right or not? That is the resisting area. See, ఇప్పుడు చెప్పాను కదా, if it is, so this is one rotation of the thread, దీనిపైన మనం ఇంకో ఫోర్స్ అప్లై చేసినప్పుడు ఏమవుతుంది, ఇది గట్టిగా కంప్రెస్ అయిపోతుంది. సో రెస్టింగ్ ఏరియా ఏదవుతుంది, ఇది అవుతుంది రెస్టింగ్ ఏరియా. ఓకే, so this will be the resisting area. Then how do you calculate the resisting area? It is like this. See, this is the internal diameter, that is DC. Am I right? And this is the external diameter, that is D. Then how do you calculate that area? Yes, area is equal to pi by 4 D square minus DC square. Is it right or not? Pi by 4 D square is the total area, and you have to subtract the inner area from this. Okay, so actually pi by 4 D square, this is the total area, and if you subtract this inner area, pi by 4 DC square, if you take common, pi by 4 D square minus DC square. Okay, so this is the resisting area. Now substitute here. So sigma C is equal to P by pi by 4 into D square minus DC square. So with this you can calculate the value of crushing stress. Of course, this is for one complete revolution of the thread. If there are n number of revolutions in contact with the nut, then into n. This is common. If there are n number of revolutions of thread is in contact with the nut, then you have to multiply with n. Okay, so n is once again number of revolutions of thread in engagement or in contact, and as usual D is the nominal diameter, DC is the core diameter.